Hello dear students, today I will continue the exercise 13.1. So question up to 16 we have completed. Now solution of question 17. Exercise 13.1. Question is cos 2x minus 1 by cos x minus 1 x tending to 0. We have to find the limit. Okay. So the limit x tending to 0 cos 2x minus 1 upon cos x minus 1. So this is given limit. Okay, we have to find the value of this limit. This is the function, rational function, numerator and denominator. Here x tending to 0. If we put x equals to 0 here, cos 0, 1 minus 1, cos 0, 1, 1 minus 1, 0, denominator 0, numerator also 0. So, we see that here we see that at x equals to 0, the function takes the form 0 by 0. The function takes the form 0 by 0 form. Okay, so we are trying to some other technique in such a way that we can find definite value by putting x equals to 0. So trigonometric, this function is involving trigonometric function, so we can use trigonometric formula. So we know that cos 2x equals to 1 minus 2 sin square x. Also cos x equals to, we can write 1 minus 2 sin square x by 2. And we know that formula or basic formula, that is what? Sin x by x is equals to 1. We know that. Clear? These are the formula. So just we will use this because the function can be transferred to sin x, and then we can use limit sin x by x tending to 1 as x tending to 0. So here we have limit x tending to 0 cos 2x minus 1 upon cos x minus 1. Just this limit is equals to, we can write limit, because 0 by 0 format, so we are required to solve this by using some formula, converting, use this formula here, 1 minus 2 sin square x minus 1. Here 1 minus 2 sin square x by 2 minus 1. So this. Now Here we can see that 1 cancel, and just we can write sin square x upon sin square x by 2 after cancellation of this 2 and minus minus. Okay, we get like this. Now we know this is a formula, so this formula can be used in place of x tending to 0, x in place of x, just we have to put a combination that should be tends to 0. So here we can set sin square x upon x square. Limit go to also under the power. So x square also we can write x square upon sin square x by 2. Okay, just we are doing what? X square multiply numerator and denominator. This is one combination, this is also, this is by 2 x square. Here we can write 1 by 2, 2 by 2 also. Just multiply. Then now we can write sin x by x square, this into, just limit distribute as a multiplication. Here we can write limit x tending to 0 x square by 2, this 2 upon sin square x by 2. Here 4, just take 4, 2 square, 2 square. We can write like 2 square upon 2 square. Just multiply for setting in this form. Okay, so x square by 2 square, x square by 2 square. And we have 2 square also. Okay, this. Now we can write limit x tending to 0 sin x upon x, this square into limit x tending to 0 1 upon sin square x by 2 upon x by 2 square into 4. 2 square 4. So this is sin square x by 2 upon sin x by 2 upon this, go to the 1 by 0. Here we can write this as like this, sin x by 2 upon sin x by 2 and into 4. Can write separately also like this, limit x tending to 0 4. 4 is constant, so limits 4. Now limit of this 1 as x tending to 0, this limit 1, so 1 square, x tending to 0, here x by 2. Since x, just write here after this line, we can, after this line, this is 1 square, limit 1 square, here 1 upon this, so limit go to numerator and denominator, so here 1 upon this, so 1 upon, we can write limit x by 2 tending to 0 sin x by 2 upon x by 2, this into 4. We can write like this: x by 2 tending to 0, as x tending to 0, x by 2 tending to 0, as x tending to 0. Since x by 2 tending to 0, as x tending to 0. So, this is also 1. So, 1 into 1 upon 1 square, also here square, 1 square into 4. So, this is equals to 4 is the limit. Just we are setting in the standard limit form, in the form of a standard limit, just like this. Okay. So this is the limit. Question 4. Limit 4. Now question 18. Ax plus limit x tending to 0, ax plus x cos x. See here, 18, limit x tending to 0, ax plus x cos x upon ax plus x cos x upon b sin x. b sin x. Okay, it is also of the form x equals to 0, sin 0, 0. 0, 0. So 0 is 0. Here we see that at x equals to 0, the function takes the form. Here we see that at x equals to 0, the function takes the form 0 by 0. So, just we will try to convert this function in such a way that by using a standard limits formula, we can get some definite value for x equal to 0. Okay. So, here we can write, then just take common. So, we have limit x tending to 0, ax plus x cos x upon b sin x is equals to limit, take x common, and a plus cos x upon b sin x. Just we can write like this. Just we are trying to do something so that we can find limit by using standard formula. So here we can see that x tending to 0, x upon sin x. X upon sin x, we can take together this into 1 upon b into a plus cos x. So limit x tending to 0, 1 upon sin x upon x. You can write like this into limit x tending to 0, 1 by b into limit x tending to 0, a plus cos x, because limit is distributed as a multiplication. So here we see that 1 upon limit go to the numerator 1, limit 1. So x tending to 0, sin x by x into 1 by b because limit of 1 by b is 1 by b, and limit this a plus cos of 0. Just we can get definite value. So limit of a is a, and limit of cos x is cos 0, 1. This is 1. So 1 upon 1 into 1 upon b into a plus 1. So limit is a plus 1 upon b. This is limit a plus 1 upon b. Okay. So using here which formula? Since limit x tending to 0 sin x by x is equals to 1. This is our main formula. Just we use this formula here in this place. Okay. Now take question 19. Question 19 is very simple question. X sec x, because x sec x means question 19 limit x tending to 0 x sec x. We know the limit of cos x is 1, that is this can be written like this, limit x tending to 0 x upon cos of x. This is just distribute limit x tending to 0 x upon limit x tending to 0 cos x. So very simple. Limit will be what? Here after putting x equals to 0, this is 0 upon this is 0, that is 0 upon 1, so this is 0, 0 is the limit. Okay, 0 upon 1, denominator is finite, I mean numerator 0, that is 0 is the limit. Okay, so 19 simple question. 20. Here sin ax plus bx, x tending to what? 0. Okay, question 20. Limit x tending to 0 sin ax plus bx, ax plus bx and ax plus sin bx. Ax plus sin bx, and AB is not equals to 0, also a plus b is not equals to 0. This is given. Just you have to find the value of this limit here. We can say sin ax plus bx upon ax plus sin bx. So just after putting x equals to 0, numerator and denominator 0 by 0. Here we see that at x equals to 0, the function takes the form 0 by 0. So for solving, just we require that just do something here so that we can use our here, because related to sin x, so we can use limit x tending to 0 sin x by x is equals to 1. Limit finding is very very important, because for the derivative finally you have to find limit. Limit is very very important. Limit and derivative, this chapter is limit and derivatives. Derivative is what? A limit. So for finding derivatives of some function by first principle method, that is finding limit. So limit finding is very very important for you. So do most of the questions from your exercise, and also examples and other books you can refer. Okay, so here, so we can write limit x tending to 0 sin ax plus bx upon x plus sin bx. Limit x tending to 0 sin ax upon ax into ax plus bx. This is in numerator, and denominator ax plus sin bx upon bx into bx. Just we multiply in this term sin x in numerator and denominator. Here bx in numerator and denominator. Okay. Now since limit distributed, so we can distribute limit in numerator and denominator. Okay. So here we see that limit is distributed to x tending to 0 sin x by x into x plus limit x tending to 0 bx. This is the numerator. Just limit is distributed in numerator and denominator. Here limit x tending to 0 ax plus limit x tending to 0 sin bx upon bx into bx. Just limit is distributed, numerator and denominator, and also distributed to within plus sign. Okay, so here as x tending to 0, x also tending to 0, bx also tending to 0. We know x tending to 0, then a is constant, so ax tending to also 0, bx tending to also 0. So here we can write limit ax tending to 0 sin ax upon ax into limit x tending to 0 x plus limit x tending to 0 bx upon limit x tending to 0 x plus limit bx tending to 0 sin bx upon bx limit x tending to 0 bx. Clear? Now this is equals to 1, this is equals to 1 by using this formula, because bx, ax, ax. So we can use here 1, here 1. So after using that 1, we get what? After this line, just this is 1. So 1 into limit x tending to 0 ax plus limit x tending to 0 bx upon here limit x tending to 0 ax plus this is 1. So 1 into limit x tending to 0 bx. Okay. Now if we put x equal to 0 here, and again 0 by 0. So just we are trying to get definite value. For that, just in numerator write x tending to 0 x plus bx, and in denominator also write limit x plus dx. Now we can write like this: limit x tending to 0 ax plus bx upon ax plus bx. Okay, so limit x tending to 0 1 equals to 1. So 1 is the limit. Okay, 1 is the limit. So here, because x tending to 0, if we put x equal to 0 here, then 0 by 0. So we do like this: limit of this upon this, same quantity. Since x equal to not 0, so this and this cancel 1. So limit 1, 1. 1 is the limit. Okay. Now question 21. X tending to 0 cosec x minus cot x. Cosec x minus cot x. X tending to 0. X tending to 0 means cosec x. Cosec x means 1 by sine 0, 1 by 0 infinity. Cot x, cos by sine, that is infinity. That is here at x equals to 0, the function takes the form, here at x equal to 0, the function takes the form infinity minus infinity. Because this is infinitive, or x0, 1 by sine 0 infinitive, so it is also cos by sine infinitive. So we will try to use some procedure that you can find definite value by using the standard formula related to trigonometric function at x equal to 0. So here we can write cos x as 1 by sin x. Cos x and cot x, cos x by sin x. So at that case, So we can write limit x tending to 0 cosec x minus cot x limit x tending to 0 1 by sin x cos x by sin x. This will be the format. Cosec x equals to 1 by sin x minus cos x upon cot x means cos x upon sin x. So take LCM. In such a case, whenever two rational functions is plus minus, that is just like this infinite minus infinite form, just you have to use LCM technique and then solve by using trigonometric formula sin x. So 1 minus cos x. We also know the formula limit x tending to 0 1 minus cos x upon x is equals to 1. Sorry, 0, 0. This is little 0. And also sin x formula. Limit x tending to 0 sin x by x. These are formula we know. This is also formula. Cosine series you can use here, or either otherwise you can use also formula cos 2 theta formula also here can be used. Okay, the x tending to 0 1 minus cos x upon x. It can be used because cos x series start from x square. So 1 minus 1, when start from 1. So 1 1 cancel x square and 1x cancel x 0. So this is equals to 1 minus cos x by x equals to limit of 1 minus cos x by x tending to 0 equals to 0. This is also or one of the important formula was, so I think you can remember it. Okay, so 1 minus cos x by x tending to 0 is equals to 0. This is a special formula, so we can use here 1 minus cos x. So just 0, 0. 1 minus cos x by x limit 0, so we can set like this 1 minus cos x by x multiplying x by sin x. Just doing this we can get this to combination. So like this limit x tending to 0 1 minus cos x upon x. This is first and also distributed limit x tending to 0 x upon sin x. So this is equals to 0 into limit x tending to 0. So it can be written like this: 1 upon limit x tending to 0 sin x by x, because it can be written 1 upon sin x by x. Limit of 1 is 1 and limit x tending to 0 sin x by x 1. So this is equals to 0 into 1 upon 1 equals to 0. So limit is 0. Limit is 0. Okay, so 0 by 1. That is 0. Okay. So limit is 0. So here main thing is what? Formula 1 minus cos x by x tending to 0, 0 limit. Okay. So this limit is 0. And this limit is 1. So we can get its limit as 1. But in the given format, they are infinite one and infinite form. So just we are doing like this, using this formula. We can get limit as 0 of question 21. Now 22. 22 is 10 to x by x minus pi by 2. Ten to x by x minus pi by 2. 22. Just limit finding what? You have to remember that whenever we get after putting tending value in the function 0 by 0 format or infinity by infinity or 0 by 0 or infinity minus infinity plus infinity, then we are trying to some method so that we can find definite value of the given function. So here 22 limit x tending to what? X tending to pi by 2, 10 to x by x minus pi by 2. Pi by 2, 10 to x by x minus pi by 2. Limit x tending to pi by 2, 10 to x by x minus pi by 2. Here at x equals to pi by 2. If we put x equals to pi by 2, then this is 0, 10 pi by 2, 10 pi 0. So the function takes the form 0 by 0. Okay. So let x minus pi by 2 equals to y. Just do something. This substitution is we have to use for finding this value of this limit. So here x minus pi by 2 equals to y. Then we can see that at as x tending to pi by 2, x tending to pi by 2, this is 0, y tending to 0. Okay. Then as x tending to pi by 2, y tending to 0. Okay. Now, so let this then. You get limit x tending to pi by 2, 10 to x upon x minus pi by 2. This limit, after substituting this, so limit y tending to 0. Here, what? Y tending to 0 and 10 to x. So 10 to x to x. Here x equals to what? X equals to y plus pi by 2. So we can write 10 to y plus pi by 2 in place of x, just put value, and x minus pi by 2 y. So it can be written y tending to 0. Clear? Y tending to 0. So here we see that what? 10 to y plus pi. 10 pi plus 2y. So we know 10 pi plus 2y, 10 pi plus theta equals to 10 theta in third quadrant. So 10 2y. So this is equals to limit y tending to 0, 10 2y upon y. Clear? Now 10, just we can use also direct formula 10x by x limit 1, or also you can convert it in terms of sine and cos. So here we see that limit y tending to 0, 10 can be written as cos sine 2y upon cos 2y into 1 upon y. So this can be written limit y tending to 0 sine 2y upon 2y. We can write 2y tending to 0 also, since as y tending to 0, 2y tending to also 0. So we can write here also sine limit 2y tending to 0 sine 2y upon 2y, and 2 is here, numerator and denominator, and 1 upon limit y tending to 0 cos 2y, because cos 2y is denominator, in denominator, so limit go to denominator, y tending to 0 cos 0 1. So this is 1, this is 1, so limit will be 2. So here we can see that limit of this, limit y tending to 0 sin y upon y equals to 1. Also this is our formula. So this is 1 to 1 by 1. So 1 into 2 into 1 by 1 equals to 2. So 2 is the limit. 2 is the limit. Okay, here main thing is what? This substitution. After substitution we get this. This 10 pi plus 2y equals to 10y. So this is also, here 2 can be adjusted. 10x by x limit 1 you can use direct, but by converting sine by cos, so you can get also using this limit the value like this. Cos 0 means 1. So this is the solution of question 22. So limit. Okay, now we are having question 23. Okay, so 23. Find limit x tending to 0, x tending to 1, fx where 23. Given. Here function is given in the form of discontinuity form, that is in 2 interval. Here fx equals to 2x plus 3, 2x plus 3 and 3x plus 1, 3x plus 1. Here x is less than equal 0 and here x greater than 0. We have to find limit x tending to 0 fx and x tending to 1 fx. Just these two values we have to find. here the function is defined like this. Its domain is very clear, that all the real numbers, but in two parts, value of the function are given by different form. So in two part means what? Just like this is 0, this is left side, and also with this is left side x greater than less than equal 0, and this side x greater than 0 from here. This side is here, and in this side this is value, that is left side of 0 here, right side of 0 here. So here the value of function is here what? 2x plus 3, and here 3x plus 1. So in this form the function is given. So left side and right side is here. So here we use the definition of limit as a left hand derivative and right hand derivative. If both limit equal, then limit will exist and equal to this equal value. Okay, but for this case at x equal to 0 we use left hand limit, right hand limit, because left side of 0 and right side of 0 is given in the function. So we have to find left hand limit and right hand limit. If equal, then that equal value is final limit for 1. But here 1 is, suppose this is 0, then 1 here. So just left side, just right side of 1 for both these two sides. The value of function is 3x plus 1. So for left hand limit at x equal to 1, for right hand limit at x equal to 1, we can use same function. We can use same function for finding value, because from in this side, because 1 is here, here also value of function is this. Here also the value of function is this. So for left hand limit and right hand limit for x equal to 1, we will use this function only. For 0, we use left for left this, for right this. And if they are equal, then we can say the limit exists. Okay. Now, for this, we see that for finding limit x tending to 0, limit x tending to 0 negative means left hand side of 0. Left hand side means this fx, that is limit x tending to 0, left side value this 2x plus 3. This is equals to what? 2 into 0 plus 3. We can use 3 is the limit. Left hand limit is this, and right hand limit 0 plus. Right hand limit fx. Here x tending to 0. In the right hand side case, this 3x plus 1. So this is equals to, we can write 3, 0 plus 1 equals to 3. So both are equal. Then left hand limit fx equals to right hand limit, plus sign for right. Both are 1. This is equals to limit of x tending to 0, pure limit of fx exists. Because if left hand limit, right hand limit equal, then pure limit exists and equal to that equal value. Clear? Now for x equal to 1. For x equal to 1, okay, so this is the technique for finding limit in the case of this type of discontinuity function. Okay, so the value of function is given in different intervals. So here for second, and also we see that for limit x tending to 1 negative at 1, left hand limit at 1 fx equals to limit x tending to 1, left side of 1 is this, right side of 1 is also this, because x greater than 0. So in both cases we will use this. So 3x plus 1. This is equals to what? 3, 1 plus 1 equals to 3 into 2 equals to 6. And also for right hand limit, x tending to plus 1. Just we use like this, limit x tending to 1. Also use this 3x plus 1. So 3x plus 1 equals to 3 into 1 plus 1 equals to 3 into 2 equals to 6. Therefore, limit x tending to 1, left hand limit, and also limit x tending to 1 from right side fx, both are equal 6. So limit x tending to 1 fx, x tending to 1 fx. So this is limit is 6. Okay. So here just left hand limit, right hand limit both same, because here x greater than 0 and x greater than 0 inside. So one left side of 1 and right side of 1 should be same value of the function here. So use this value in both cases. So both limits exist, and this is equals to 3 and this is equals to 6. Okay. Now question 24. Given 24 here, just we have to find the limit x tending to 1 fx, x square minus 1, fx x square minus 1 and minus x square minus 1, minus x square minus 1, x less than equal 1 and x greater than 1. Okay, x less than equal 1 and x greater than 1. Just given like this function, we have to find limit x tending to 1 fx. Here x tending to 1 fx. Breaking at 1. So just for left hand limit use this, for right hand limit use this. Here we see that left hand limit at 1 fx, limit x tending to 1, left side is this, x square minus 1. So this is equals to 1 square minus 1 equals to 1 minus 1 equals to 0. And limit x tending to 1 plus fx, right hand limit. Right side x greater than 1. Right side is this. So limit x tending to 1 minus x square minus 1. So this is equals to what? Minus 1 square minus 1 minus 2. Okay. So we get left hand limit x tending to 1 minus is not equals to x tending to 1 right hand limit. Not equals to. They are not equals. Left hand limit 0, right hand limit minus 2, not equal. Which implies that limit x tending to 1 pure limit fx does not exists. Limit does not exist. Okay. This. If both limit are equal, then we say that limit exists. And here both limit are not equal, so limit does not exist. Okay, this is question 24. Now remaining questions we will solve in next class, and you have to do all these questions and also examples in your copy and send me to the solutions for your attendance. Okay.